Hello dear students, welcome back to my YouTube channel. I hope that you know that in today's lecture we will be ending our AC chapter. That means today we will be having a last lecture on AC. And this last lecture will take, I guess, less than an hour, right? So within an hour we will complete the AC. From today, most probably we will start EM waves. Am I audible and visible? Yeah. So I am audible and visible to you also. Let me check the connectivity firstly, then we will start. Okay. I am facing some lag in network. I hope you will understand the issue now. Now let us start class. I guess the screen is visible to you. I hope the screen is visible to you. Done? Is the screen visible to you? Yeah. Okay. So today is our lecture number 5, and lecture number 5 is the last lecture. Lecture number 5 is last lecture of AC. So within 5 lectures, we completed our AC, and within next 2 days, we will complete EM waves. Then we will start modern physics. And after the class, we will just discuss our next plan. Look now. So we will start the class with doing a simple numerical. Okay, this is my numerical. Let us read the numerical firstly. And numerical is like: an iron cored coil is connected in series with an electric bulb, okay, with an AC source. As shown figure, as the iron piece is taken out of the coil, how will the brightness of the bulb change? Done. So if you need to get its answer now, so we have to go back to the EMI chapter. EMI. In EMI, we concluded if we are having any sort of solenoid, what is magnetic field of the solenoid, or what is the inductance, right? I guess it is L. L equals to, it is nu naught N square by L into area. Look, this formula is valid only for air or vacuum. But if we are having, this is my solenoid, and we are placing a rod. Now here we are having a rod, iron rod inside it. It's my iron rod. It's my iron rod. So now if you need to write, it is L. So L equals to nu naught nu R N square by LA. Equation first, equation second. As we introduced this iron rod, you can see my L increases. My L increases, right? You can see now, look, it is nu naught same. You can see now my L increases. My L increases. So what is L now? Let us take an example. What is XL? Inductive capacitance, sir, it is omega times L. What will be the impedance now? Sir, it is R square from bulb, then XL square. Now see here, if my L increases, my XL will increase. My XL will increase, my Z will increase. My Z will increase according to the Ohm's law, V equals to I times Z. If so Z is inversely proportional to the I. If Z increases, I will decrease. But here it states that we are having the iron rod, then we take out the iron rod. That simply indicates my L decreases. If L decreases, XL decreases. If XL decreases, my Z decreases. If my Z decreases, that means my current will increase. If current increases, which state is that? My brightness will increase. My brightness will increase. My brightness will increase. So from this first numerical, we concluded that the brightness of the bulb will increase if we are taking out the iron rod. If we are taking out the iron rod. Done? We are having one more thing in your NCERT. So from NCERT, you will find one thing. In your NCERT, you will find one thing, that means metal detector. Topic is airport metal detector. Metal detector. Suppose we are having a metal detector. This is my metal detector. So here we are having a person, and this person is carrying some iron. Let us suppose some iron. Okay. This person try to cross this metal detector. When the person crosses it, that means L is introduced. How, sir? Look, basically this rod is not a rod, it is a coil. This is a coil. A coil. This is a coil, right? Look, when we know that if we are having a solenoid without what? Without iron, so my I will different. It is I1. And when we are having an iron rod here, we are having I2. So that simply indicates that upon introducing an iron thing, there will be a fluctuation in the current. And how, sir? Because look, when iron is there, so we know that when we are having the metal will increase the I. When L increases, so XL equals to omega times L increases. XL increases. That means Z increases, that means current will decrease. So you will see there is a change in current. Whenever there is a change in current, this thing will set up the alarm. That means whenever we are taking any metal thing with us, and when we are crossing the metal detector in maximum airport, bus stand, railway stands, right, in shopping complexes, there will be a beep. You will find the beep in the metal detector. Beep is just because of the fluctuation in the current. Why there is a fluctuation in the current? Because metal rod introduced in the circuit, there will be a change in the L, that will change the XL, that will change the impedance, that will change the current ultimately. Hello, beta. Asan, you are late, no? You are 12 minutes late. Now, next numerical. We are having a very big, a huge numerical on the screen. And numerical is like an inductor of inductance L, a capacitor of capacitance C, and a resistor of resistance L are connected in a series to an AC source of potential difference V volts, as shown in the figure. Potential difference across L, C, and R is 40 volt, 10 volt, 40 volt. Done. The amplitude of current flowing through the LCR circuit is this much. That means the amplitude means my peak value, is it I naught? I naught is given to us under root 10 under root 2. So what will be our IRMS, sir? IRMS equals to I naught by root 2. That means it is 10 by root 2. Here is root 2. Cancel out. It is 10 ampere. So my IRMS means 10 ampere. Okay. So what I need to get? I need to get impedance. So what is Z? Sir, Z equals to Ohm's law. Now, is it V by I? V by I. So V is VRMS and IRMS. So what is VRMS? it will be VR square plus VL minus VC whole square root. Then we are having IRMS is 10 Z. What is VR? VR is 40, right? 40 square. Then 40 minus 10 is, it is 30 square. Root by 10. 1600, 900 divided by 10. 2500 divided by 10. 2500 divided by 10. So how to find 2500 now? 50-50. It is 50 divided by 10. My answer came out to be 5. 5. So answer is 5. Easy numerical and a good numerical. You will find a lot of things given to us, but the effective one is only the 1-2 lines, right? So my Z came out to be 5 ohm only. Easy? Easy, right? Okay. Now let us start a different topic. It is not a different one. Look now. We are having a something like this. Omega frequency graph with the current. And we know that it is graph is somehow like this. So look, this one is my peak value. That means resonating value. At this value, we will get a peak current. But if we drop here, now look, here we are having two equal points. Two equal points. Here at this two equal points, my current is I naught by root 2. Maximum current by 2. This particular thing is known as W1, omega 1. This one is known as omega 2. These are some frequencies. So omega 1 or omega 2, these are called half power frequencies. Okay, look now, you will get your half current. That's why it's known as half power frequencies. Aruniva, beta, we are not taking any separate segment now. We are taking NEET and JEE combinedly, right? Because here some topics are deleted from NEET, but they are asked in the JEE. That also I'm taking the classes. Okay, just like LC oscillations. LC oscillation is deleted, but you will find 2024 you got a numerical from the LC oscillations, right? I will take that thing. Okay, look now. So these are omega 1 and omega 2 are known as half power frequencies, and the width of these things, is known as delta omega, and delta omega is known as bandwidth. Delta omega is known as bandwidth. Then what is bandwidth? The gap, the space between half power frequencies. And bandwidth, it is not, you don't need to derive it. The half bandwidth is known as R by L. Just remember this formula. Bandwidth is known as R by L. Look now, this one is omega naught. So what should be this thing now? Sir, it is delta omega by 2. This thing also is delta omega by 2. Look now, can I write now delta 1 equal omega 1 equals to omega naught minus delta omega by 2, and omega t equals to omega naught plus delta omega by 2. I think I can write this thing now. I get it easy. I can write this thing now. Omega 1 half power frequency equals to omega naught. That is resonating frequency minus delta omega by 2. Look, this is what? Omega naught. So if you just minus omega naught from this one now, so you will get this one only, right? Delta, it is omega naught minus delta omega by 2, you will get omega 1. Same for omega 2. And do you know what is P average? How you will say that it is half wave, half power, right? P average is I square RMS R. Look now, if your current becomes I naught by root 2, So what is square of it? Sir, it is I naught by root 2 square. You will get I naught by 2. So look now, if you are squaring it now, you will get 1 by 2 things, right? This is what? This is half power. That's why you will get half power frequencies. At this particular width, that means omega 1 and omega 2, you will get your power as half. That's why they are known as half power frequencies. Half power frequencies. I know that my video is getting stuck, but there is some network issue today, right? Okay, then we are having a quality factor, Q factor things. Then we are having a Q factor thing. I will write Q factor, quality factor. You know what is quality factor? Look now. If we are having two graphs. Look now, it is first graph. Let us study about first graph. Look here. If you want to check its width, width is only this right now. Band width. Look, peak is same. If you want to check its width, this is a band width of second one. Delta 1. So you will write delta 1 of first one is less than delta W of 2. What does it indicate? That means sharpness is more. Sharpness is more. Simply indicates, let us suppose you are having a radio. Sundarja, from 15th of September, I will start 11th. And before December, I will complete your 11th. Don't worry about 11th, right? So look now, let us suppose you are tuning your radio, right? We have the frequencies, right? FM radio, we have the car, in our mobile phones. When we are tuning it, so you know that at a particular frequency, let us suppose 92.7, we are getting now. Look, 92.7 and 92.6. Look, when you tune it now, we know that it is 92.7 FM. Okay, but when we are going to 92.5 or 92.8, we are getting nothing. The clear audio we are getting, it is 92.7. That means when we are going to this particular thing, we are getting sharp things, no? But when we are coming down sharply, we are getting nothing. We are getting late nahi ho jayega. Your examination is in March. You need to revise your 11th stuff. So you will repeat your 11th stuff from the January. So Jan, Feb, you're having 2 months for revision. So I will complete your 11th before December. Now that means September, October, November, December. I will complete your whole syllabus before December. Don't worry about anything. I am with you now. Don't worry about anything. Okay. Look now. Is this one is good? Or one more example. We are having 92.7. Then we are getting some information at 92.3, 92.9. First condition, second condition. We need to tune at 92.7, but when we are going to 92.3, we are getting some harsh things. No, we are not getting clear thing, right? When we are going to 92.9, we are getting some unusual things, not a clear one. That means this particular thing, the quality is not good. You were right, sir. The quality factor of this thing is not good. Why? Because when we are tuning to 92.3, we are getting some information from this one. When we are going to 92.9, we are getting some information from this one also. That simply indicates it is not a very good junction. So apart from this one, if we are going to 92.7, good things, we are getting a great information, and it is not sharing it is information to 92.5. When we are tuning to this particular frequency, we are getting nothing. We are getting different things. When we are going to 92.8, we are not getting any information from this one. No, it simply indicates this one is quality is very good. How quality is good? Because it is bandwidth is very small. The small bandwidth, the great quality. So now if you need to define the quality, it is Q, which is equal to resonating frequency divided by bandwidth. Now frequency is 1 divided by under root of LC. This one is R by L. R by L. I can write 1 divided by under root of LC multiplied by L by R. So I can write it as a 1 divided by R under root of L by C. If Q needed to be maximum, which indicates 1 by R under root of L by C. L needs to be maximum, C minimum, R minimum. If you find a numerical where you need to find the quality maximum, good. So there your R should be minimum, C should be minimum, but L should be maximum. Done, beta? Easy or super easy? Easy or super easy? Huh? This one done. This one done. This numerical now. This numerical now. Okay, numerical like when a coil is connected to a 100-volt DC supply. Okay, that means we are having a coil. It is 100-volt DC supply. Look, coil means it is RL circuit. Coil means RL circuit. So we are having the supply 100-volt, but DC. You can see it is DC supply, right? Current is 2 ampere. Current is 2 ampere. When the same coil is connected to the AC source, current is 1 ampere. The inductive reactance, that means XL, we have to find out. Look now. So this is my R, this is my L connected with DC supply. DC means frequency 0. If frequency 0, what is XL? 2 pi F times L. So my XL is 0. If my XL is 0, so what is now a resistance of it? All the things, right? So we know that V equals to IR. V is 100, I is 2, R we don't know. So my R came out to be 50 ohm. R is 50 ohm. Now the whole thing is connected to the AC supply. AC. So what is VRMS? Sir, VRMS means it is IRMS into Z. VRMS is how much? It is 100. 100. IRMS, sir, IRMS is 1. What is Z? It will be R square plus L XL square. I can write 100 into 100 square. R is how much? R is 50. It is 50 into 50. Then it is plus XL square. It is 100. Look. 1, 2, 3, 4 minus 2500. Then root, it will be XL only. So you can write it is 7500 under root of XL, which came out to be 50 root 3 ohm. Only calculational thing, nothing more than that. Only calculational things. Easy or super easy? Easy or super easy? Okay, next numerical. Okay, this one now, and I hope that you can do this one now. I hope and I assume. This one is on the screen, and numerical is like which of the following combination should be selected for better tuning? What is better tuning? Q should be maximum. For Q maximum, R minimum, C minimum, L maximum. Look, R minimum 20, 25, 25. No, that means this one is good. Okay. L C minimum, C 35, 45, 45, 30. This one is good. That means this one. Option number third. Within 2-3 seconds, you will get this numerical done. Okay. Now next one now. Next one now. Next one now. Numerical like, which are the following combination? No, we have done this one, no? We've done this one. This one now. Okay. And numerical like, a series LCR circuit containing 5 Henry inductor, 80 microfarad capacitor, 40 ohm resistor is connected to 230 volt variable frequency as AC source. The angular frequencies of the source at which power transferred to the circuit is half the power. What is given to us? Half the power at the resonant frequencies are likely to be. So do you know what is asked for? Omega 1, omega 2. What is omega 1? Do you know? Omega naught minus delta omega by 2, omega naught plus delta omega by 2. What is omega naught now? What is delta omega? So delta omega equals to, is it R by L? R is 40, L is how much? 40 R, L is 5. Again it is 8. What is omega naught? Omega naught equals to 1 divided by under root of LC. What is L? 5. What is C? 8 10 to power minus 6 root. 5 is a 40. It is 1 divided by 40. It is 400. 400. It is 1 divided by 2. Then it is 4. 4 is 2. 10 to the power minus 2. So it is 100 by 2, which is 50. Now this one now, first one, omega 1, omega naught, it is 50 minus 4, and omega 2 is 50 plus 4. That means it is 46, and it is 54. 46, option number 3 is correct now. Option number 3 is correct now. Okay. Done. Now, last topic, LC oscillation. Oscillating now, it is oscillation. LC oscillation means it is deleted. It is deleted. But if you open your NCERT, you will find 7.7 numericals, unsolved one. Unsolved 7.6, it is based on LC oscillations. LC oscillations. So we don't need to take any risk. We will complete the LC oscillation. In LC oscillations, we are having a capacitor, we are having an inductor. Okay. Initially, my capacitor is full charge. It is full charge. Now we close the key. What will happen now? Charge flow from my capacitor to inductor. So what will happen now? Capacitor start discharging, and my inductor starts charging. After some time, it will get full charge and completely discharged. Then my charge will flow from inductor to the capacitor, then capacitor to inductor. It is oscillating between capacitor, inductor, capacitor. This is why it is called LC oscillations. That's why it is called LC oscillations. Done. So what you will find now? Look, what will they will ask you in the examination? Maximum current in inductor. Maximum current in inductor. Look now. What is 1 by 2 Q naught square by C? Capacitor 1 is equal to 1 by 2 L square max inductor. 2 cancel out. So I came out to be, is it Q naught divided by under root of LC. Done. And what is omega? 1 divided by under root of LC. So you need to remember only these equations, nothing like that. But I just completed, na. Last topic, then full stop. I completed the chapter. Arunava, beta, I just completed the whole chapter. Okay, this was the last chapter. This was a miscellaneous one because you will find one numerical in the NCERT. That's why I just give you some information about what LC oscillation is all about and how you will get I maximum current and what is omega, the frequency part, right? Everything is sorted up to this point. Now, from this point, I will say we just completed AC. Now we are having EM waves. We will start EM waves. It will take two lectures. Then we will start modern physics. Okay, modern physics. Then we are having semiconductor. Then we are having optics. And my aim is to complete before 15th of September. It's my aim to complete the whole syllabus before 15th of September. Okay, beta. And if you want the complete notes, that means handwritten notes of AC, EMI, magnetism, current, electrostatics, capacitor, you need to go to the description part of the channel. You will find a Telegram link. There you will get my Telegram ID. In my Telegram channel or a group, I had posted each and everything about the class. You will find the whole PDFs there, right? You need to click on the download. You will get the download file, the PDF one, the handwritten one. And I guess everything is done now, right, beta? So thank you for your response. I know that now sometimes there is some issue, network issue, right? So I can get it now. But thank you, beta. Good night. Bye. If you have any query, I am here for 2 minutes. If you have any query, I will just ask. I will just give you a response, right? No worries, beta. If you have your notes, that is good, no? Don't worry. I didn't make these notes specifically for one student, no? This is for general one. If you need, you can get the notes. I'm just showing. No worries, no worries. Thank you, beta. Thank you, beta. Good night. Bye. Take care.